Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is the final video in a series of videos on solving trigonometric equations. The first video was the concepts behind solving trig equations. The second one was solving basic trig equations. The third one was solving equations requiring the use of identities. And the last one we did was solving trigonometric equations involving multiple angles. This video is just dedicated to a few examples, about 3 I think, involving technology or requiring technology. I titled it Equations Requiring Technology and a Warning. It's not that the equations require a warning, but they actually do when you're using technology, so I might as well just say it that way. So here's my statement. Whenever you're using technology to solve a trig equation, there we go, you will be using an inverse trig function. Only do so with the absolute value of the trig function's value. This will always give you the reference angle. Now, before I go into an example, I just want to showcase what I mean by that, because I think a lot of people will just say, what did he just say? So if I said we have the tangent of theta is equal to, I don't care, -3, doesn't really matter. It would be very bad of you to say that theta is tan inverse of -3, because that is, you're just saying I only have one solution. That's bad. There's an infinite number of solutions to this equation. Tangent of theta is equal to -3 at an infinite number of points. So saying that theta is a single value is incorrect. Also, saying theta hat is equal to that is completely incorrect, because that is not the proper reference angle. A reference angle is never negative, and tangent inverse of a -3 would be a negative angle. So when you find the reference angle using an arc function like the arctangent here, or the arccosine or the arcsine, always do so without the negativity on the number. That'll give you the actual reference angle, and from there you can finish solving it out. That's literally the only thing you have to worry about. Okay, why this is so very important is because of the cosine function, really, but it just makes more sense if you just do it always this way. So for example, let's solve this equation. Now you should note, if I drew out the sine curve forever and ever and ever and ever and ever, okay, I'm really asking, when is the sine at a height of -0.8? It's going to hit that height an infinite number of times. It continually crosses that height of -0.8. So if you grabbed a calculator and just said, well, that's the arcsine of -0.8, you'd get one solution and you'd be done, and that would be bad. There are an infinite number of solutions here. So we'll start by saying that our reference angle is equal to the sine inverse of 0.8, not a -0.8, but 0.8. Because again, reference angles can't be negative, and sine inverse of a -0.8 would return a negative angle. So if I grab a calculator and I did the arc sine of 0.8, I get 53.1 degrees. So they didn't tell me what angle measure I should be using, so I'm just going to use degrees here, mainly because in applications, degrees are the best to work with. They're just easier to kind of work with. And now we'll talk about the quadrants. Well, I know sine is negative in quadrants 3 and 4, so I just go ahead and write out my quadrant 3 and 4 solutions. Quadrant 3, reference angle of 53 degrees. My actual angle is 180 plus that. And let's see a little bit of math in my head. 2033, so 233.1 degrees. And in quadrant 4, oh, by the way, I should say plus 360K, right? Because we want all solutions. So I should have had a plus 360K there. Sorry about that. And then in quadrant 4, we'll have 360 minus. Now, in this case, I'm actually going to go ahead and just say it's a negative 53.1 degrees, because that's a quadrant 4 angle as well. And then I'm just going to add 360K to it so that I get all solutions. And there you go. Those are the solutions to this equation, the infinite number of solutions. So the arc sign only returns one of them, but I have to actually write out all of them. That's why I use the reference angle. Now here's the one I really want to focus in on. The cosine of 3x equaling a negative 0.594. If you have the propensity, the likelihood of not removing that negative when you find the reference angle, you'll be very surprised at what the cosine inverse returns. So in reality, our reference angle, 3x hat, should be the cosine inverse of the positive 0.594. If you want to ignore everything I say and just go and grab a calculator and plug in cosine inverse of negative 0.594, you will get arc cos of negative 0.594. Oops, that's supposed to be a point. Boop, there we go. You will get an angle that cannot be a reference angle. Reference angles are between 0 and 90 degrees, and this is 126 degrees. So this is completely out of the ballpark. So the reference angle has to be found using the positive ratio, and that reference angle is 53.6 degrees. Once you have that, you're pretty much almost done with the problem. We know our solutions are going to occur in quadrants 2 and 3 because that's where the cosine is negative. So our angle 3x, because that's what the angle is, it's not x. Our angle 3x in quadrant 2 is going to be 180 degrees minus that reference angle, 53.6, plus 360K. Let me make sure that I didn't really care. Good. I want to make sure I could do degrees here. Now, you'll need a calculator to probably figure out what 180 minus 53.6 is, and then you need to divide that by 3. 180 minus that 53.6 is 126.4, which was the actual angle that was handed to us via the cosine inverse of that. But that's okay. So I'm making some room here. So this is equal to 126.4 degrees plus 360K. And now I'm just going to go ahead and divide both sides of this by 3 so that x is equal to 126.4 divided by 3 is 42.13. And I'm just going to round it to the nearest decimal place because it actually is not exactly that. And then plus 360 divided by 3 is 120. And then we do the same thing for quadrant 3. Our angle in quadrant 3 will be 180 plus the 53.6 degrees. And then we have a rotation of 360 degrees thereafter. That is equal to 233. All right, 233.6 plus 360. And then dividing both sides by 3, we get x is equal to, I'm going to do this, 233.6 divided by 3. We get 77.9 roughly degrees plus 120. Okay. So there are our two sets of answers. That's pretty much it. My warning was just really to always do your inverse trig functions with the positive ratios. I hope you know that by now. This final example is actually just to let you know that you should know when to hold them and when to fold them. It's an old song. Anyway, you should know when to walk away and when to run. This right here, you cannot solve by hand. 2 raised to the sine of x equals x. You must be aware when you've been defeated. So if somebody says solve this equation, the fact that it's a mixture of trig functions and algebraic functions, and it's within an exponent as well. It doesn't have to be. It'd be very difficult just to solve this. But it's even worse when it's 2 to the sine of x. So when you're faced with that, there's just no way to do it. You have to use a graphing device. And you just want to know, when does y, which is equal to 2 raised to the sine of x, when does that equal y equals x? When do those 2 curves run into each other? And you can see they only run into each other once, and they do so at x equals 1.919. If you need more digits, I think you could just zoom in on Desmos. So if I click here, it gives me 4 digits. I don't know if it'll ever give me 5 though. Desmos is weird like that. So I'm trying to zoom in, but I don't think it'll actually give me any more than 4 digits. So 1.9187 roughly is the solution to that. All right, so that's all I have for solving trig equations.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.